In this video, we're going to continue our discussion about the application of the properties that we previously learned. We have the power rule, we have the quotient, product, and property 5.4 and 5.3, I1 and I2. So our objective in this example is to write each logarithmic expression as a single logarithm. So we will condense the expression. In our previous example, we expanded the expression. This time we will condense. So we will do the other way around. So for A, we have 5. As you can see, we have this expression. Minus this one, 4 times the log of y base 3 plus 2 times the log of 3z. So our objective is to write this one in a single logarithmic expression. So let's write this again as 5. So this is actually equal to, if you are going to examine this one, this expression, you can rewrite this as, okay, this one this will become an exponent of x, so we will apply the property 5.7. So we will apply the power rule. Okay, so this one, this becomes the exponent, so this becomes the exponent now. So applying 5.3, this becomes log 3 x raised to 5 minus, similarly you have log 3y raised to 4 plus logarithm 3z raised to 2. Okay, now we can group these things since all of these three expressions here represents real number. So now we can actually group this one first so that we can apply property number property 5.6, which is this one, and then eventually we can turn it into this expression since they are just equal. So here this becomes, so we will group this one, and after we will group this one, so this becomes log 3x raised to 5 over y raised to 4, then copy log z squared with base 3. So of course, as you can see, we will apply now so for this expression we will apply property number 5.5, the product rule. So this one, so remember the property that is log b mn is equal to log bm plus log bn. So this one is actually in this form, so we will transform that in that form. So this becomes then multiply x raised to 5 over y raised to 4 times z raised to 2, then simplify further, you have log 3, so this becomes x 5 z2 over y raised to 4. And so we're done because we've already expressed this logarithmic expression to a single logarithm. So we're done. Similarly, for letter B, we will do the same. We will apply the properties. So this is A, this is B. So first we will arrange. Okay, this one is this expression. I think we can use property 5.7. We will make this as an exponent, as well as for this we will make it is as an exponent. So this is equal to raised to 3, applying property 5.7 plus log b of raised to 2. We're applying property 5.7 again. Right, so this one is actually this. In other words, we'll just making this as an exponent. Okay, so just continue. Now we can now group the expression. There are 3 terms here. Let's say I group the first 2, or you can actually group. You'll come up with the same answer if you group this way. Let's say this one and this one. You'll come up with the same answer. But be careful with the minus. Okay, so if you try to group this becomes log by3 z2 minus the logarithm of b x, then this becomes minus. Okay, this one, my negative is negative, negative times negative, we have positive. Okay, so we have to be careful with the signs, no, when we group. So if I group the first 2, which is easy, so we will apply now the property 5.6, which is the quotient rule, if you can still remember the quotient rule. So the quotient rule, log b of m over n, that's log m. So this one is basically this one. So we will turn this into an expression that looks like that. So that becomes log b of our n is y3z2 over x square root of y raised to 3 plus, just copy the remaining expression, and then we will combine using property 5.5. That's the product rule. So when this is plus, meaning we're going to multiply this one. So this will become and so we can simplify now this expression, this one. That's 1/2, so 3 over 2, then z2. So just simplify everything. So for x, it's clear that That's x already. Just have to cancel this out. Then you're left with 1. So that's why x raised to 1. Z2, 0 is to 2, so that's cancelled out. This one and this one, so you have to subtract 3 minus 3 over 2, that is 2. 6 minus 3, it's 3 over 2. So the answer is y raised to 3 over 2. Since 3 is greater than 3 over 2, so the answer will be at the top. Okay, the same position as the expression with the highest exponent. So we're canceling this out already. So we're left with this expression now. Okay, so I think we're done. We've already expressed this expression to single logarithmic expression, which is this one. So we're done. So that's how you're going to apply all those properties, or some of those properties. Okay, the last topic will be the change of base formula. For the change of base formula, let a, b, and x be positive real numbers. So all of these numbers are assumed to be, this one are all positive numbers. So it must be greater than 0. So all of this must be greater than 0. With an exemption that a must not be equal to 1, although this is positive, but it is stated here that a must not be equal to 1 and b must not also be equal to 1. So a and b here are not equal to 1. X can be any positive, so we're not restricted, just like a and b. So now this is called the change of base formula. So log x with base a is equal to the log of x with base b. Now you can choose any base b. Okay, you can choose any, as long as b is a positive real number and b is not equal to 1. So as you can observe, in the left side, b is not there, alright? But here on the right side, b now becomes the base. B here, you can choose any b, as long as b is not equal to 1 and it is positive number. Okay, so that's equal to log b, okay, log x with base b, you can choose any b, over log of a with base b. Okay, so this one right here, so actually this one and this one is for the base. Or you can have log a of x is equal to ln x, this one, over ln a, if ever our b will be equal to e. Okay, so this will be the case if your b will be equal to e, or the Euler's number. Okay, why? Remember our log, using this becomes log log ax is actually equal to log of b, you can choose any b, x over log b of a. Now if b is equal to e, the Euler's number, that is 2 point something, this becomes log x over the base e over log of a with base e. You know, this one is equal to the expression ln x. So that becomes ln a. So that's why this one is equal to this one, right? Okay, so example, we use the fact that log 132 with base 10 is approximately 2.121. This is actually calculated using our calculator. Log of 8 with base 10 is approximately 0.903. So these are the values, approximated values. To evaluate log 8 132. So in this example, we will use b. We will choose b to be equal to 10. Usually, b will be equal to 10. Okay? But we're not restricted. That b can only be 10, because here in our discussion we've learned that b can be any positive number and b must not be equal to 1. So usually b is chosen to be 10. Okay, so our b here will be 10. So in this case, in this example, we will use b to be equal to 10. Okay, so we let, in this example, b equal to 10. So using the change of base formula, so that is to evaluate this one, we will answer this one. So log of 132 of base 8, using the base change formula, this becomes log 132. We will use the b, which is 10. So okay, the base is 10, so log 10 of 8. So we will calculate this one. We already have an approximated value. Okay, so now this becomes, should be approximately 2.121 over the approximated value for log 810, that's 0.903. So that will be equal to, if you divide this one, so we have 2.121 divided by 0.903. So the answer is approximately equal to, so we will just round this off to 3 decimal place, 2.349. So that will be the answer for log 132 with base 8. Now we will try using another base. Okay, let's say our b now is e. Okay, so let's see if we can get the same answer. Okay, so if we let b be equal to e, that's the Euler's constant, 2.71. So using the base change formula, we will evaluate log 132 base 8. So using the base change formula, that becomes log our b, remember, is e, so that's x over log of e of 8. Okay, so our, that's, so remember, log e, that's ln x over ln 8. So that is, if we're going to calculate ln, I'm sorry, it should be ln 132. So calculate ln 132. So that is approximately equal to 4.883. 3 decimal. We will use only 3 decimal. ln 8, that is 2.079. Now we will divide. Okay, right here I have to use equals. Okay, now here we have 4.883 divided by 2.079. The answer, okay, I'm going to use approximate here since we are rounding off. So the answer here is approximately 2.349. So we get the same answer. This time we're using different b, but we got the same answer. Now this one is approximately equal to 2.349, and this one as well is approximately equal to 2.349. So this is the change of base formula. So that would be all for logarithmic function and their properties. Next time we will deal with equations that involves logarithmic expressions. So thank you very much and have a nice day.